So Renee, today we've been talking about ecosystems, and I've heard about this interesting case where there's a lot of organisms that look like they should be from a lush green rainforest, but they're actually in the Australian outback. Is that where you've been working?
Yeah, you've got it completely right. The area that we think of desert now actually used to be a rainforest. But as the continent shifted and climates changed, it dried up and slowly became a desert. But lucky for some of these rainforest species, there were these permanent pockets of water, tropical kind of watery habitats that were left behind. Okay,
and tell me about the springs that you've been studying.
So I work on a very special kind of springs. They're a very unique Australian ecosystem. They're special because they're fed by a thing called the Great Artesian Basin.
The Great Artesian Basin spans a large area of Australia. It's one of the world's largest and deepest aquifers. Aquifers are layers of rock underground that contain water. This water is around 3 kilometres below the ground surface. In places with a split or fracture in the rock, water can escape to the surface and bubble up to form these springs. And unlike rivers that rely on water from upstream or billabongs that rely on rainwater, these springs permanently have water bubbling up from underground. Those springs form ecosystems where these rainforesty type creatures can still live, even though it's the dry outback. What sort of organisms have been found there?
So we've been discovering lots of animals, and up to today we think we've got about 100 species that are only found in the system. But one of those that lots of people really love and is really special is a little fish called the Redfin blueye.
The red-finned blueye fish is only 3 centimetres long, making it Australia's smallest freshwater fish. And they're critically endangered. They only live in these springs at the Edgbaston Reserve in central Queensland. Although they have a permanent supply of water here, the deepest springs here are 8 centimetres deep and some are only 5 millimetres deep.
There's about 100 springs in the area, but the fish actually only lives in about 5 of them, and only one of those is an original population. So it occupies essentially the amount of area it can live in is less than a rugby field worth of habitat. So at the same location where the redfin blueye lives, there's 9 species of snail that are exactly the same. They're only found at that location, and most of them are restricted to only a couple of little ponds.
The spring species at this reserve are living in a delicate balance, with the threat of climate change, a history of habitat degradation from pests and cattle, and this invasive fish. This is the eastern gambusia, or mosquito fish. But how could this introduced species threaten the animals that live here?
It causes threats to different organisms in different ways. For the redfin blueye, the special fish that's from our springs, it actively attacks redfin blueyes and eats their eggs. So it's really aggressive to the native fish.
So what are you actually doing, or what are scientists doing to try and protect these species?
They've done things like building fences around the springs to stop the gambusia, the invasive fish, from getting in. But another cool thing that we've been doing recently is building these kind of mini ecosystems, replicating what a spring is like, but in a really safe area that the gambusia can't get to.
Protecting these natural springs from threats and recreating these micro-ecosystems elsewhere is no small task. But hopefully, with science and conservation on their side, the unique species in this amazing ecosystem can thrive again.